Alright, this is notes 10-4, exponential and logarithmic forms of equations. Very, very simple stuff. Okay, if you notice up here at the top, it gives you kind of a write-up of how you convert from log to exponential, and you can go vice versa. As we had last time, the base still stays the base. Okay, whatever is with the log goes across the equal sign, and whatever was on the other side of the equal sign becomes my exponent. So, as we notice on these first ones, we don't know what is missing, okay? But we can put in our calculator log base 2, 8 and get this number. And we know that that number, okay, would be like this k here. It would be the exponent for this one. So I take my calculator, I crank it up. So these are all gimmes in my calculator. Okay, log base, and I type in log base 2, 8, and hit enter, and it tells me 3. So we know this is a 3, which then goes here, because whatever's on the other side of the equal sign is the exponent. Base stays the base, equal sign flips over to this side, whatever's on the side of the equal sign on the log flips up as my exponent. Okay, so same thing here. Okay, we don't know what this guy is, so we can find it though, because we know what 2 to the 4th power is by putting it in our calculator. 2 raised to the 4th power, hit enter. It's 16. So I know this has to be 16. Base is the base. The exponent goes across the equal sign. Okay, whatever's on my, with my log is on the other side of the equal sign here. So 2 to the 0 power, we know if we put in our calculator, anything to the 0 power is 1. So this is log base 2, 1 equals 0. Okay, same deal here. We want to know what to the negative 1 power is 1/2. Okay, and then it would go down here for our base. So this is our base. So what base would have to be here for it to be a 1/2? What did we do with numbers if it was a negative to get it to not be a negative?
Put it under 1.
We flipped it, okay? We put it under 1, but in this case, that's what was already done, so what does that mean it had to have started at?
As a negative?
Well, no, it was a positive, but it was a whole number. You said put it under 1. So what was under 1? 2. So this has to be a 2. 2 to the negative 1 power, to get it to not be a negative power, I just put it under 1, and that's how we got 1/2. So that'd be 2. Okay? Now, what to the 1/2 power is 2?
Negative?
Okay, if I put a negative 1, then that's going to give me a 1 for my power. So it needs to be bigger. What's 1/2? 1/2 of what number is 2?
4.
4. So 4 to the 1/2 power would be 2. Okay? Same thing over here. Here's the problem. It gives me a variable, so there is no way for me to solve this. Okay? So we have to put in a variable, and we use the variable k for a constant, so we just put in k. Alright, that's because it gave me a variable to start with, and it's asking me for another unknown. You can't have 2 unknowns. That's like having 2x plus 3y and saying, alright, what's the value of y? Well, we don't know the value of x to be able to tell you the value of y. That's 2 unknowns. Okay, so now we're going to write these in the other form. So if it's a log, I want an exponential, and vice versa. So here we go. Let's practice these, and you'll see how easy it is. Number 1, it's a log, so I'm going to convert it to exponent. What's the base?
3.
3. So it stays the base. The exponent is whatever's on the other side of the equal sign. So it'll be a 4 equals 81. If you want to check your work, you can put 3 to the 4th power in your calculator, and it's going to tell you it's 81. Okay, so number 2, what's the base? It's a log, converting it. 4 to the what power? First power equals 4. Next one is an exponent. We got to convert it to log. So log, what's the base?
8.
8. Okay, what do you think goes here? You only have 2 choices.
64.
64 equals 2. And if you put in your calculator, log base 8, 64, hit enter, it's going to tell you 2. Okay, this there's another exponent. So log base what? What's the base on it?
5.
5. What goes here? 1 equals 0. Too easy. Told you guys, this stuff's easy. Flip it. Don't even worry about that, what it says. Evaluate logarithms without using a calculator. Watch this. Using a calculator.
Well, it disappeared.
Because we're going to use them anyhow, aren't we? So might as well. So here we go. Crank up old handy dandy.
I like your thinking.
There we go. Springtime thinking, right? Log base 5, 25. Hit enter, and it tells me 2. Log base 4. $64, and give me what? Let me do it. 3. Number 8. If I put that one in, watch what happens. Oh, get off me. Log, get off me. Log
Non-real answer.
base 4, negative 16. It's going to tell me not real answer, or non-real answer. So this one is no solution. Okay. Next one, it's a base, but also notice that this guy is raised to a power. So I would simply always go to number 2, clear that out. Log.
If you go up, if you click up 2 times, it'll be faster.
If I click up 2 down whenever you're doing it.
When you go to like math and then click up 2 times, you'll get the log base.
Oh,
faster.
because it's at the bottom of the list.
Right.
So log base 10, 10 raised to the 3rd power
3.
is 3. Okay, so what you're saying is go math, go up 2 times, and it gets to it faster. Log base 3, and now we have a fraction, alpha y equals, number 1, 1/3,
-1.
and you got -1. Okay, log base 9, 3, you got 0.5 or 1/2, either way you want to write it. And we have last one, log base 16, 1/2, yep, is negative 0.25, or you could put negative 1/4, it's up to you. I'll put negative 0.25, you could have put negative 1/4. Okay, too easy, any questions on this? Told you it's the easiest one yet. You're doing A10-4. On A10-4, you're going to have a few of these, but remember they're quick and easy. Okay, on 10-4, we're doing numbers 1, 3, 5, 6, 8, 9, 10, 13, 16, 17, 18, 20. Remember, most of them you're just plugging in and hitting enter, or just doing the conversion. 25, 27, and 31. This concludes the notes for 10-4.